All right, well, let's roll into it.
I can't believe you're proposing that we put off our procrastinating.
Welcome to the Hackaday podcast. My name's Mike Szczys. I'm editor-in-chief of Hackaday.
Hey, I'm Elliot Williams. I'm managing editor of Hackaday.
This is episode 115. Today we're talking about how AI is bad at the Linux terminal, puppeting Pico in Python, and 3D scanning comes up short. Elliot, we flew something on Mars.
I didn't fly anything on Mars.
We as humanity collective.
Yeah, we did.
Yeah, as scientists.
And none of those
collective.
space rockets that landed there carrying robots count.
Yeah, I thought about that because there was the Sky Crane thing that had
Dude.
like 8 jets on it, right?
Yeah, and that took off in the other direction after it dropped the rover.
Yeah, that is technically powered flight. I think you're right. I wondered about that, but I didn't look it up. I wonder what the distinction is. But in this case, we've never launched a vehicle from the surface of Mars, I don't think.
Ah, good. Well, it's definitely the first helicopter on Mars.
Yeah. Oh, yeah, we're bearing the lead. The Mars helicopter. It's the Mars helicopter, in case you're confused about which amazing science thing we're talking about. Goes by the name of Ingenuity, was shipped to Mars on the belly of Perseverance, and it popped down and dropped off and has been hanging out on the surface of Mars for, what, like 3 weeks now?
What needed a software update?
Yeah. So they tried to spin it up and things didn't go too well and they had to rewrite the software. So Dan wrote a great article. Go back and look on it. He also wrote a wonderful article on the helicopter like a while ago. That one came out, actually, that came out in September, Elliot.
Yeah.
But it's a good one. It goes into all the stuff that's, hard about this one. I think for me, the most interesting is you can put it like they do for spacecraft in a chamber that adjusts for atmospheric density and temperature, but you can't adjust the gravity of the planet. And so there was no real way to test this in the exact same circumstances. And so it was, I think, a very important experiment to establish the dynamics of flight on Mars.
But there's like all sorts of crazy X factors with thin environments and helicopter blades. And I was reading up on this because a little bit of an aero geek sometimes. And it turns out the thickness of the medium that you're running the blades through determines what kind of oscillations go on in the blades. And so one of the things they're really worried about with Mars's thin atmosphere is not the obvious thing, which is spinning them fast enough to produce thrust. But because the atmosphere in Mars is so thin, it doesn't induce the same damping forces on the blades, and they can get like these kind of chaotic twisting motions. And if they end up being self-reinforcing, the blades rip themselves apart. So there's all sorts of like crazy stuff that you don't think about until you try to do something like this. So it's really neat to see all of these challenges kind of beat down and see the thing actually fly.
Can you imagine how crushing it would be if you spun it up and the propellers just self-destructed?
After you just sent it out to another planet.
Yeah, but it went up 10 feet and it hung out there and then went back down and seems very successful. So, yay. It's just damn cool. And to be around and see it, like I think I've said before, some of the earlier Mars missions, they weren't really on my radar. So we can go back and relive them now. But to like wait for the video to come back.
Yeah.
And, that's pretty awesome.
What else is going on?
I got some time and built an apparatus for my own experimentation on Earth, not on Mars.
Earth experimentation? Tell me about it.
Run a lot of articles about projects that are using PID loops, right? This is like foundational to control theory. And I get it. I understand how it works. But I just want to like write my own PID loop from scratch so that I can play around with it and make sure that, my understanding of it is where I think it is. So Electro Noobs a while ago built some balancing apparatus with a ping pong ball and a distance sensor on one end.
Okay.
The balance is controlled by a servo. So I had some time on Saturday morning, I guess it was Sunday morning, and I went down and just built one of these out of all the scraps that I had. Awesome. And got it working with the servo so it's going up and down. And I put a photo up on Twitter and I was like, great. And then, Monday night came and I was like, okay, I've got this time of flight sensor. It's the VL53L0X.
Those things are awesome.
Yeah, they are. It's really cool. It does millimeter precision to like 2 meters.
Yeah.
I think. So it's perfect because this thing is, I don't know what it is in metric. It's 20 inches wide, but it doesn't work.
The sensor doesn't work?
the sensor doesn't work very well. And actually, I went back and watched Electro Noob's video again once the sensor didn't work, and they're using an infrared distance sensor,
Sure.
like a Sharp, one of those Sharp ones. They're pretty common. Yeah, he just throws it in at random. He's like, I have one of these time of flight sensors, and it won't work past 20 centimeters. And that's the problem that I'm having too. I think what it is, so they're not laser. When you say time of flight, I think laser, but these are not. These are LED based. And so it's flooding some type of light pattern out and then reflecting back. And I think the problem is this V-shaped track that the ping pong ball goes in is picking up some of that light and reflecting it back. And the further the ping pong ball gets away, the more that light builds up and interferes. And at some point, the sensor just sees that distance as like there being an obstruction there.
So it works in the minimum distance, and then once it gets further out, it fails. Yeah, I bet you're right. I bet it is reflections off the track.
Yeah, it fails right about where like the pivot on this balancer is.
Yeah.
So it's like no good. But I'm not thwarted yet because I did pick up some OpenCV demonstrations on ball tracking.
Okay.
So I think I can just plop a camera in front of this.
Oh, that's a good idea.
Do ball tracking. Because like I said, I just want to play around with the algorithm. I don't really care about the physical build's not going to sit on a shelf behind me balancing ping pong balls for the rest of my life or anything.
That'd be cool too, because then you can do a little CV stuff, which is fun. That's the way to do it, man. Now you've got two problems. That's awesome.
Oh, don't worry. There are more problems coming.
There will be. You'll find that little servo's got enough play in it. It's got too much slop in the gears that it drives your system crazy, and you're going to have to damp it. And that's going to be fun, dude. I'm jealous.
And this is because of you, because we were talking on the podcast about those little MG90 servos.
Yeah.
And so while we were talking on the podcast, I got on AliExpress and ordered a bunch of them, and they came like super fast for that platform, like 4 weeks or something.
Sure.
So it is like a very, very tiny servo, but I'll keep you updated.
Good. All right, let's talk some hacks.
Yeah, this first one, I like it. It is a DJI Mini 2 drone hack. And in this case, adding extra channels to what the drone is already doing in the form of tapping into the RGB LEDs that are on the aircraft. It turns out that these are addressed in a similar way that WS2812 LEDs are addressed. Apparently, these are at 780 kilohertz. It squawks out 48 bits every 20 milliseconds. The phone app for the DJI drones has the ability to change the colors on screen. And so if you want to add like an extra bit of data channel on there, you can tap into those LEDs and just watch for the data that's coming down for like the red, green, or blue channel. This was figured out by Terev3, who ended up using just the green channel because a bunch of the different colors have a value between 0 and 255 on there. And it's reliable because it's digital. So you just wait for that to come across, and then the microcontroller, which in this case is a PIC 18, can do whatever it wants with that data.
That's so rad. I saw this and I was like, oh, that's clever. He's got a 3 LED, an RGB LED, and he's tied it to respond to one of the channels. And that would work too. But since it's a digital LED, if they only gave you a better color selection, like if you could define any of your colors, you would have a 40-something, whatever it was, 48-bit signal to send to this thing. That's crazy.
It's like 16.5 million different values if you can dial in RGB to any value you wanted.
Yeah. So in this video, he's dropping a parachute from the thing, and I can imagine putting 16 million parachutes to drop from it.
Well, he's dropping a parachute. That one, whatever, that's playing around. But at the end of it, it's really cool because he's got a little rover on like a tether. So you can think of it as like a crane helicopter lifting up a little rover, and you can take it wherever you want and then drop it off and then drive the rover around remotely, which is kind of an awesome concept to play with. I thought the actual hook mechanism on this was interesting as well. There's a little motor that I guess unlatches whatever it's carrying around. And he didn't want to brown out the board. Like he didn't know how much he could get from the 5-volt rail. And motors can have a kind of a kick to them when you turn them on, or like if they get jammed or something. And so he put a tiny battery on it that its purpose there is to run the motor. But then the battery is like sipping off of the 5-volt supply. So it'll be very slowly charged by the battery of the drone at the same time.
Well, my first hack this week is a camera hack, peels back layers of embedded Linux. This is an IP camera hack by Felipe. He has taken apart a Foscam C1 IP web camera and wants to, well, hack it. Don't you all, Liz? And so the first thing he does is finds a serial port on it and then goes looking for the flash chip that holds the embedded Linux system. It turns out it's underneath the camera, so he has to pull that off first and then pull out the flash. But that's not so hard to do. He desolders it and dumps the flash. I thought it was interesting. He uses a tool I didn't know. One of the things I always love about these reverse engineering hacks is that I get to learn more awesome reverse engineering tools. And here he uses a simple flash dumper called Flash ROM. Put the links in the show notes. It's a catalog of all sorts of SPI flashes and their sizes and, how many bytes per page and stuff like this. And so it makes dumping an arbitrary ROM really, really simple. And in this case, he even is able to hook just 3 wires directly from his Raspberry Pi using the Raspberry Pi's SPI and this flash ROM software to dump the ROM. So he dumps the ROM and starts poking around in there, finds bootloader password, finds the root password, but the root account never gets fired up anyway, so it doesn't really matter, but, have some fun cracking passwords. And then in the end, goes after the firmware upgrader, which has an encryptor, so any firmware you submit to it to upgrade it yourself has to be encrypted. And then he finds that part of it, and ta-da, he wins.
I really like to see that tool Ryzen on this one that did so much awesome stuff. Had you come across that one before?
Ryzen, no, but Ryzen is a fork of Radar and of Radar 2. And that's a really awesome tool. This is a fork of it done by some of the original co-developers of some of the tools in Radar. So I don't really know what's going on here, but I think there's been kind of a parting of the ways. But Ryzen has also taken the nice Cutter GUI with it as well. I don't know, Radar was always based on command line and was really aimed at being kind of, I don't know, not simplistic in that sense, but being very easy to use because command line and not entire IDE. That may be part of the reason for the split, actually. I shouldn't speculate. You guys are all out there listening. Both Radar and Ryzen nowadays have kind of interoperability plugins with Ghidra. And so combining them all together gives you the best of all the worlds.
It's just, once you get this flash dumped, you got this block of code and what do you do with it? And very simply showing how to use Ryzen to pull out the partition tables so each different type and where it starts. And then he, uses DD to break those apart and then starts drilling down into them that way. It's like this peels the sticker back for you so you actually have something to work with.
I don't know. Have we seen a webcam that isn't hackable in the end when you're able to, that's the beauty of these things is that they've got embedded Linux systems in them. They're asking to be hacked, but some of them provide more challenges than others. And this one with the encrypted firmware upgrader definitely did. But yeah, it gives Felipe a little bit of room to stretch his muscles.
Continuing on with our reverse engineering tools, or maybe this is just engineering tools, bridging the PC and embedded worlds with Pico and Python. This is a great little project that Alexandra used to turn a Raspberry Pi Pico, the new RP2040 dev board that came out just a little while ago, into, I would say, a Swiss Army knife for embedded development. It's not unlike other things that we've seen before, like the Bus Pirate or the Good FET, the Great FET, people that are just using simple targets like a Blue Pill or a Nano in order to connect them to chips and sensors and be able to access them through a serial terminal. But I really like this one because it took a little bit of different tilt to it. So you could take any board running MicroPython on it and you can serial into the MicroPython terminal or an interpreter and try and, address whatever chip is connected to your board. In this case, it takes like a chunk of that MicroPython environment and it moves it onto the host, onto the computer that you're connected to. And so then in your Python script on your computer, you can import machine, which for anyone that hasn't tried MicroPython before, that is what has like the pin definitions in it and, timers and everything that you would want to do with that specific piece of hardware then available to you. And what this means is you could use the Python interpreter on your main computer to address this board and whatever I2C or SPI or ADC thing that you're trying to do. But you can also script on it without then transferring that script onto the flash on the board that's the target.
Yeah, I love these kind of little remote controlling / puppeting microcontroller projects because it's so easy to do all the big coding on your computer and write all the hard stuff on your computer. But at the end of the day, you need something to like do the SPI communication for you or do the hard timing stuff. And I remember back when the Bus Pirate was new and Travis Goodspeed's GoodFet was hanging around. And I was always like, I don't need either of them. I'll just code up an AVR to do whatever I want. And I was young and ambitious back then. But now I'm old and smart and lazy. And this kind of like little devices to make that access a lot easier for you is really super. And I do think there's kind of a philosophical difference between things like the GoodFet on one side, which was a little bit of C code on the PIC, and then a Python library to remotely drive it, like Puppet it, like this one. And then the things like the Bus Pirate, where kind of all the action happened on the device itself, and you were just talking to it over serial. And I really do like both modes. They both have their pluses and minuses, and like the puppeting one is kind of a lot more data needs to be shuttled back and forth, and it's a lot less real time on the microcontroller side. But it lets you do more of the hard coding on your big computer, and vice versa, of course. This has been reinvented a million times by a million people, and I love each and every one of them. All right, my next hack, I think it's got its tongue firmly planted in cheek, but I'm not 100% sure. This is AI makes Linux do what you mean, not what you say. And River has gotten his hands on the GPT-3 AI speech recognition, meaning interpreting AI monstrosity. And so he can pay a little bit of money to have it do its magic, and decides to solve a problem that really matters in the world, which is how do you make Linux work from the command line? So he's written basically a small Python script / shell that takes whatever you say, feeds it off to the AI, and then the AI tries to come up with a Linux command that will do what you want it to do. And the video is pretty funny. It's got a lot of kind of some false starts, some that work surprisingly well. His write-up of it is even better. You should really go check that out because it includes a lot of the stuff that didn't make the video. I think this whole project shines a light on what these kind of AI models are good at doing and what they're not good at doing, and that's really interesting. The GPT-2 and even more so GPT-3 have such a gigantic corpus to draw on. You can say, start talking to me about some kind of philosophy, and they can carry on like they really know what they're talking about. It definitely sounds like it understands what's going on, and there are some actually interesting academic papers at the moment about how much of this is just parroting things and how much may be actually kind of synthesizing ideas together and whether that constitutes machine understanding. And there's a really neat kind of counterpoint to that here. He says download ie5dom.exe to the machine, and the machine comes back with a wget command, which is already awesome. And it comes back with a wget to a download.microsoft.com/download/ blah, 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 numbers / authentication key / ie5dom.exe. And you think, oh, that's awesome, great. But it completely made up the GUID. And this is exactly like when you get it to tell you about historical people, it tells you about made up historical people. Only here you're trying to get it to actually get you something that must exist in the real world. And so it's getting you something that's really a lot like what a Microsoft download link would look like. Like, that's a convincing Microsoft download link. I was convinced. Microsoft servers, however, were less convinced.
You're like, who taught this AI to lie, Elliot?
Yeah, right? It doesn't lie. It just draws on kind of big averages and rolls some dice and comes up with whatever it comes up with.
It really is like the guy that's like, that's close enough.
Well, it doesn't know any better. And I think this is part of the point. And this is where this is a counterbalance to the kind of how much is it learning? You know, is it just repeating what we say, or is it synthesizing new ideas? But you're right. Maybe it's just getting creative with the URLs. One of my favorite aspects of this is that he includes a flag. In fact, I think there's only one command line flag to run his shell, and that is -- live dangerously. And if you run with this flag, it'll just do it without prompting you, without asking you if it's the right command. Because River's not dumb enough to just let it do whatever it does. He's actually gonna double check it before it like completely nukes his hard drive or whatever. And I love it because he includes this flag, which is a really horribly dumb idea, and then tells you, of course, in all red not to use this flag.
I think this needs to be unleashed on a Twitch channel, and you need to let people just type in with the live dangerously flag. You know, it popped to mind, but then I was like, well, it only takes one person to be like, delete the root partition and to see what happens, you know? I mean, you would have, what you'd want is to have it on a loop, so it would auto restore itself if it nuked the system.
Right. Oh, you'd put it in a VM and you just spin it back up when
Yeah, because eventually those jokers will tire of that, and then the real creativity will start.
I love, this is the most like postmodern thing. He's got an API key, and this gives him the opportunity to pay per submission to have this AI give him crazy results that then he decides to use or doesn't use. And the idea of having it nuke his system is so beautiful to me somehow. Like, it's almost artistic.
Speaking of artistic, I really loved seeing this dead blow hammer built this week by Ebonisteri Eloise. She goes into a little bit, I'd say, out of the ordinary tool making in the end, because there is kind of a leather sheath that goes on it, and the leather work on that is just beautiful. So make sure that you watch to the end, because I was kind of surprised by that. But the core of it that caught my eye is just the engineering that goes behind it. A normal dead blow hammer is filled with like sand or steel shot, and when you hit something with it, those loose particles absorb the reflection of your force. And so with a normal hammer, if you hit like something metal, you might end up with like several half moons from the hammerhead where it like bounced back onto the metal. And this can get around some of that. Beyond that, you know, people that are tool aficionados, I don't really understand too much about a dead blow hammer, but it gives you an idea of where we're going. And in this case, the really interesting thing is that fluid dynamics are used instead of sand or shot in the form of 4 brass cylinders that were turned. They have a solid brass piece with a narrow channel all the way through it, axially inside. And then the thing is filled with baby oil, so that when you hit it, this counterweight inside can move, but the oil has to squirt through that narrow channel, which is a slow process, which turns it into a shock absorber. It works remarkably well.
Yeah, and that's what I loved most about this, is that there is actual testing going on here. It's one thing to make up your own crazy novel fluid dynamic damped dead blow hammer, but it's another thing entirely to have it work extraordinarily well. And she tests it by, you know, hitting them, and there's great video sequences of, you know, rebound on a normal hammer, rebound on a stock dead blow, and rebound on this thing. And dang if it's not the best dead blow hammer I've ever seen.
Yeah, those test apparatus are just a vertical ruler.
Drop it and measure it.
Yeah, the cylinders are filled with, you know, one is just filled with like bolts, so it's like solid metal, or sorry, nuts. and then another is filled with sand. And actually, the sand performs twice as well as the bolts at dampening the recoil. Filling it with the liquid mechanism, it's 4 times better than the sand, so I guess 8 times better than the solid. I guess the last thing I didn't mention is there is a spring also inside of the fluid-filled cylinder, and that's to keep the counterweight on the correct side. Otherwise, just like setting it down, you wouldn't know like which side the dead blower works on. So you need some active element in there so that it's always ready. It does, however, make it a one-dimensional hammer, Elliot.
You have to hit it on the right side.
Yeah, exactly.
Yeah. My last hack this week is Acid Bourbon's first radio hack, a super heterodyne receiver with a 74X twist. This is lovely. This is what happens when someone who likes analog and digital electronics but doesn't like radio decides to make a radio. The post goes into a lot of the kind of theory behind how heterodyne radios work, but the short story is you generate a frequency that's near the one you want to listen to, and then you mix them together, and that creates these sum and difference products, and then you just listen to the sum. So what it does is it strips the carrier off, and then you have to do a bunch of filtering, and there's all sorts of mess. And ham radio people make these things traditionally by like winding up coils and using funny germanium diodes and things like that. And Acid Bourbon, Michael Weibusch, wants absolutely none of that. This is using, quote, no special magic radio diodes. It's lovely. So it uses a 74HC 4051, which is an analog switch, as a mixer. He also uses another logic chip, a 4046 PLL, as the local oscillator. And just one of my favorite, actually, Jelly Bean op amps, the NE5532, as a bandpass filter and doing the ideal diode for rectification. If any of these part numbers sound familiar to you, it's probably because they're in your closet right now, and you could build this shortwave radio yourself without any hassle. PDFs are up on his website, but what's really great about this is Michael's first radio, and then he's already improving it. So there are 2 extra additions you can add on to this thing at the very end. And one of them is using a precision oscillator instead of just this PLL thing, which kind of works, but it'll drift with temperature and who knows what, and you have to tweak it yourself. He uses an SI 5351, which you can get little modules from China for dirt cheap. Speaks SPI to your Arduino and puts out a very accurate frequency reference, so you can really tune in on the channel you want. And he also designs a nice little input amplifier for it. So he starts out as not a radio geek. He builds this radio that's just made of logic chips, but then by the end, he's seen a little bit of the dark side. And I don't know. I love to see this because this is a lot of the kind of chips and analog foolery that I like to play around with. So this was so up my alley. But then I also loved seeing that by the end of it, he's starting to turn into a little bit of a radio geek.
First up on my list of quick hacks is a faux BBS gets software onto your vintage machines. So what do you do if you need to dial into the BBS with your retro hardware and there is no BBS anymore? You get a copy of this software, you run it on a Linux box that has Python 3 installed, and it lets you connect over a null modem cable if you have one of those. One of the really interesting things about this is the conversation in the comments about how you get modem software onto the machines that don't already have it. Next up, we have detergent DRM defeated on diminutive dishwasher. Dan Maloney gives Christina Panos a run for her alliteration money in this one. And it is weirdly a detergent cartridge that only allows you to use it 30 times and then you throw it away, which makes the earth sad. And so we were happy to see Deku Nukem reverse engineer this, figure out what is going on. Of course, it's an EEPROM on there that has a counter on it that's just a little bit obfuscated, but it is in plain text. Builds a little piece of hardware that you can put on there and press a button and it'll reset it. Of course, Resetting it's no good if it's empty, so he then goes over how easy it is to use a syringe to refill the dishwasher liquid and the rinse agent. And if you're scratching your head on this, it is a countertop dishwasher, so it's kind of like dishwasher 2.0 sort of stuff. Not surprised to see DRM, but I am sad by it. And finally, we have The Beat Goes On with this ESP32 page turner. This is an awesome little box with guitar pedal style buttons on it that allows you to turn pages on your various devices. I was taken by it because it uses an awesome library called the ESP32 BLE keyboard, and it makes it dead simple to make your ESP32 look like a Bluetooth keyboard.
I'm going to check that out.
I know, I need to try it. I'm like, oh, add it to my list. Once I'm done with the balancer.
Yeah, right? This was one of those weeks where there are just too many hacks, and I'm picking 4 for quick hacks, and there are some that I would have listed if I had more space. So you've got to check all of these out, I'm afraid. First up is Doom on a bootloader. Ahmad has hacked the Barebox bootloader, which is aiming to be kind of a general purpose bootloader for all sorts of platforms that has a little bit more than the barest of features. It's got a frame buffer so you can do graphics, it's got a file system, it's got simple I/O. So it is also kind of a way to bootstrap some bare metal systems, hence the name Barebox. His demo for this is that he's ported Doom to it, so you can now run Doom on any system that Barebox supports, and his idea is to fool people secretly into porting Barebox to new systems just so they can get Doom on them. Very clever. Next up, Kiwa has another Doom hack. Kitchen Bump Bar plays Doom between orders. These are those things in the back of fast food restaurants where it lets them shuffle the orders around or say, we don't have this, or I'm working on this one now. And basically inside the box is a 386 to 486 computer, and it runs DOS. So of course it can run Doom, and Kiwa gets that up and running. Also runs Windows 95 if you're into it. It's just so funny to see a full-fledged computer coming out of this thing that's meant to say, we need more taco sauce. Next up, Martin Fitzpatrick. E.T. video game gets reimagined in 10 lines of BASIC. This is one of those code competitions where you try to write software in as few lines of BASIC as you can. There are 2 categories here, one for 80 character lines and one for 120 character lines. So this is really not much code. He's written a clone of the kind of classic ill-fated E.T. video game for Atari, also a Snake. This is all running on a computer I'd never heard of, the Sam Coupe, but his write-up and the rest of his blog is super interesting if you're into coding for minimalist video games. Bringing up the rear, Uniservo. Inside a DEC hard drive, he has an old PDP-8 disk drive, and this thing is the size of an LP record. It weighs 70 pounds, and he needs to ship it to someone else. The problem is the read heads actually physically make contact with the spinning disk, and so to ship it he has to dismantle it, and that gives us all a rare chance to see what's inside a 50-year-old hard drive. And it's one platter and it's two-sided because the read heads are fixed, multiple, and in contact with it. They actually wear it out over time. And so you can flip the disc over when you're done with one side. If you've run too many grooves into one side, you can then physically dismount and flip this gigantic hard drive over. This is a lovely video, and you get to see some hardware that you would otherwise never get to see.
Now it's time for our can't miss articles of the week. This is long form content written by excellent Hackaday authors, and I picked one by Tom Nardi this week called Crew Dragon's Short Hop Begins the Era of Valet Parking at the ISS. And it is actually a pretty descriptive title. There was an event up at the space station where everyone had to get on board the currently docked Crew Dragon and strap in as if they were going home, but they're not going home. They're going to another docking port to make room for another arrival. However, once you disconnect the Crew Dragon from the space station, that's the ride home. And so they didn't want to risk having the vehicle and the people in two different places. The interesting thing, nobody was flying. This was an autonomous maneuver, and the vehicle is more than capable of doing it itself, which is interesting to me, Elliot. What do you think of it?
Let me talk about autonomous in a sec, because what's really interesting to me about this whole problem is that there are two different docking ports, but they're slightly different. And so you have to shuttle vehicles around from one port to the other. And what I didn't know is that apparently the Russians, who have significantly more docking ports and significantly more vehicles docked, have been doing this for quite a long time. Pull off, fly over to the next one, push back on. It's really crowded up there. And it was really neat that he drew out the diagrams of where everything is, and you can kind of begin to understand the problem. Does it need to be automatic if everybody needs to be in the car? Why would they do this?
I think it used to be that you had like hotshot test pilots running all of these missions now, and over the decades it's leaned much more heavily towards people that are doing science missions.
I think they all know what they're supposed to do though, right? They're all
Yeah,
trained
I think
on the
they
machine.
could, but I think the point is like if you're not doing it all the time. But I was talking to Tom on this one. It seems like no one's flying the Crew Dragon. The Crew Dragon's basically all
Right.
strapped up to get itself to the space station and dock, and then undock and get itself back. Now, it doesn't land with its jets. You know, it's got a parachute system. Although Elon Musk has said that it can land on the escape jets if it needs to, but that's not authorized by NASA. But this did spark kind of an interesting discussion that we had in a pitch meeting, is that, you know, all these things are named for autopilot. And I have this like antiquated view of autopilot being like cruise control for planes, right? Where you tell it like, we're going there and we want to go at that speed, and then you set it and it just goes. But the planes are so much more sophisticated to that. The point now is that a lot of these planes can land themselves if they need to. And they don't do it very often, but it is something that some plane models have for landing in poor visibility conditions, was actually developed by the British, because landing, obviously they're famous for fog. And so,
London.
British Airways having to land so many flights in such poor visibility, they're like, look, we need a technological solution to this. So in those conditions, it is completely possible for some passenger airliners to land by themselves. The pilot is really only controlling the speed at that point.
On commercial airplanes, everything I know about automation in commercial airlines is from a really great talk given at the Chaos Communication Congress a few years back now, 4 years ago, 33C3. The talk's called What's It Doing Now? And it's narrated by someone who is an airline safety expert and engineer. He says in the talk that in the 90s, there was this move toward always having the plane land the plane, or at least do the approach to landing. The pilots would still do the landing, but the plane would handle the approach. And that there's kind of a shift back in the last decade to having the pilots do the approach sometimes, or even all the time, just so that they can keep their skills fresh. And that a couple close calls and or accidents kind of woke up the industry to the idea that pilots might be over-relying on some of these automation features, and instead they use them only when they reduce the pilot's flying burden rather than all the time now. So it's ironically in the more recent time, pilots have been flying more than they used to, even though the autopilots perform better and better. That's super prescient, actually, that talk. He foreshadows like everything that's going on in self-driving cars and the problems that Boeing's having. You should really go watch that talk.
I'll have to go watch that talk.
This guy was seeing the future that is now our recent past.
I think it's kind of funny that we've all been kind of distracted by the self-driving cars thing. And in the meantime, we have our self-driving spaceships. They've just kind of come and taken over the way that the US is doing these space launches. And that to me feels very much like the future. Go check out Tom's article and just see the awesome stuff that's happening.
Space is easy. You can't miss. Driving cars, you have to worry about pedestrians hopping out in front of you. When you're up there, you don't have to worry about a satellite that's like gonna decide to jaywalk or anything.
I thought there was a bunch of space debris that they didn't really know where it was or how
Ooh.
fast it was going, though.
Yeah, that's probably true. I don't think they can do anything about it. I think they just take the hit when it comes. Though.
It's like your windshield on the highway. There's a rock coming right at me. What am I going to do about it, right?
All right, my can't miss article this week is Donald Papp's What to Expect from 3D Scanning and How to Work with It. And I thought this was a really honest evaluation of what you can do with 3D scans. And I guess Donald's worked with them, and so he knows firsthand. I've played around with them a little bit too, and I've done a lot more 3D design for 3D printing on my own. And I think he hits this tension between our kind of dreams of 3D scanning versus the reality. And basically, he boils it all down to 3D scans make meshes, but not CAD models. And here the difference is in what designers call design intent. When you have an STL of something, you have a bunch of triangular surfaces that can describe the object arbitrarily well if you make the triangles small enough, but it doesn't say anything about what any of that's supposed to mean. Whereas if you have a CAD model, often you're saying, okay, here I'm drilling a hole for this screw and it's going to be 4 millimeters wide. It's really easy to just go change that one variable to make it 5 millimeters wide when you change the screw you're going to use. Whereas if you're stuck with this mesh that has 40,000 surfaces on the inside of the screw, you have to move them all a little bit radially out. And it's really hard to modify in that sense. So he breaks the problem down into 3 kind of use cases that you might want to use scanning for. And one of them is to make copies of an object. And this is kind of the easiest and best case for 3D scanning. The next is to make a CAD model. He says, not really. I say completely falls down. It's just so awkward to work with a scan unless you're just going to wholly recreate the CAD model from scratch based on that scan. And for that, they're kind of useful, actually. And then his last use case is digitizing inconvenient or troublesome shapes. And his take is, does it work? Yes, it depends. And this one's actually the one that I think is most interesting for digital scanning, which is if you have an odd shape that you really can't get your calipers around. It's got a lot of radiuses. It's got some funny bends, kinks, 3D models, a funny cutout here or there. It is actually a lot easier to just scan it and then design your part to fit into that, mesh of points that you've got there. And so for that, I think 3D scanning is tremendously useful, as well as just for the simple, I need to print something that looks like this other thing.
I first ran into this. I actually got 3D scanned at a Hackaday event. I think it might have been the 10th anniversary that we did in Pasadena. And
Awesome.
The folks from D's Maker were there, like Diego, and they did like the Bukido printer.
Yeah.
I don't know if you remember that one. But
Sure.
They brought like a turntable that you stand on that was like chain driven, and then like extruded rail that stood up vertically and had a carriage on it. So it was a line scanner. And so you'd stand on this platform really still. It would revolve around as the line scanner went from bottom to top, and it took a scan of you. And what came out of it had some voids in it. And like, I didn't understand at the time, like that it's difficult to fix that stuff. I was like, oh, you can just fix it. So like looking at this hybrid, like if you're going to scan an inconvenient shape because modeling it is difficult, that's fine if you get a good scan because you can then just plunk it right in. But it gets kind of hairy if you then have to go and like repair something because it wasn't seen by the laser line or some other issue.
You always have to go in and repair it. The question is just whether the repairing it is less work than the modeling it all from first principles. And when it is, of course, or when, you need something that looks realistically like Mike's Stitch on a platter, you absolutely need to go this way. I don't know. I'm of two minds on that. I have done complete recreations where you have a picture of the thing and maybe a profile picture and a head-on picture, and you can scale the picture up and then make your CAD drawing around it. Or you can, A/B it and make your model more look like this picture and then overlay them until it looks right and stuff. And that helps a lot. It's a little bit easier in a way if you have a 3D wireframe model of it that you can also put right next to it and compare. So, in that sense, I do see scanning as being beneficial. And I don't know, is it a tool I need in my tool chest? I'm pretty handy with the old calipers and pen and paper when it comes down to it.
That's all the time we have for this episode of the Hackaday podcast. As always, we'd love to hear from you. You can leave a comment on the show notes, which you'll find at hackaday.com/podcast. You can email us, editor@hackaday.com. We live and die by the tips that you send in, so if you see something cool or you do something cool, please tell us about it. tips@hackaday.com. And until next time,
keep on hacking. I didn't write the model number down.
Right, well then let's cut that part out. I'm so out of my depth here, Elliot.
E2? Oh, E.T. video game.
Crew Dragon's short hop begins the era... Blah. I almost had it, Elliot.
And so if you want to... I gotta go one step back. I think it is there. There isn't there.